Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
data is everywhere. No matter where you go, what you see, what you do, data is there. Okay? I mean, it doesn't matter what you study, too. In your science classes, in your history classes, you use data. In your math classes, of course, you use data. But data is all over the place, and it is used in a variety of fields in different ways. So what I want to do is give you just some brief introductions into some ideas and lead you into a particular type of distribution called a normal distribution. Before we can do that, we need to revisit a few concepts that you may or may not be familiar with. First of all, there's two types of data. There's continuous data and then there's discrete data. Continuous data is basically any data that can include a number within a particular range. An example of continuous data could be the heights of all of the kids in the state of California, okay? Or if we took the time it took for all of you to finish a test, that would be considered continuous data because we'd have a lot of decimal values and numbers that are not whole numbers. Discrete data, on the other hand, is data where the values are countable. So think whole numbers. An example of discrete data would be like the scores of a basketball game, right? You would say, oh, this team won 75 to 63. You wouldn't say 75.327 points, right? That would be continuous. So discrete data is numbers that are countable like whole numbers. Now, where do you get your data from? Well, there's always an intent or a reason why you want to look at data. So you're really interested in a particular population. Now, don't assume a population is always about people. A population could be it could be talking about animals, it could be talking about products, it could be talking about, of course, people, it could be talking about opinions. There's so many different ways population is. Essentially, though, a population is all possible data that is your area of interest, so whatever you're focusing on. Suppose you were interested in figuring out what the average screen time was of all of the, let's say, adults in the state of California. Well, that would be the population. But it is impossible to survey every single person in that population. It's not possible. So what we have to do is pull a sample. Now, how big of a sample and the techniques, that's for another day. But you need a sample. Well, what is a sample? A sample is basically just a subset or a portion of data selected from your population. You pull that data, you pull that sample from your population, and then using various techniques and analysis tools, you can then make conclusions or inferences based on that apply to the entire population. Before we continue on, let's also look at what's called a histogram. So a histogram is a visual way to represent the frequency of your data. Now, don't confuse that with a bar graph. Histograms are very different from bar graphs. With this, I have a set of data right here, just random letters. And what I did is I set up ranges, and then I wrote down their frequencies. Now, the way I counted this is I said, well, let me show you. So let's say there's 3 A's, which there are. The frequency is 3. Now there's 2 B's. Now you may be wondering, well, which range does it go in? Well, according to histograms, essentially B is in both of these, but B is in the next level here. So we're going to put B into here, the B to C range here, okay? And we're going to put it in that bin. See, on a histogram, the horizontal axis is broken up by intervals, usually called bins. And so you want to think about, well, where do all these little data points go? They go into various bins. So I did that with the frequency, as you can see here. They gave me a total of 15 total data points. The relative frequency is essentially the ratio of the number of outcomes in that particular range to how many total there were. So, for example, the relative frequency of any data points that were in A to B was 3 out of 15. So its relative frequency is 0.2. So I did that with all of the frequencies here, and I got 1.00. You sum all these up. Now I did have to do a little rounding, so it's possible I could have gotten 0.99 or 1.01. That's okay. Then what I did here is I took those relative frequencies and I sketched them according to my relative frequency on the y-axis, which creates my histogram. So what's unique about a histogram is that you can actually look at these areas and they actually have meaning, whereas in a bar graph they don't. One more thing that I want to review with you is mean, median, and mode. Remember, the mean is just the average, so you add up all of the data points and divide by how many there are. The median is the middle, but the median, what you have to remember to do is arrange your data from least to greatest and then find the middle number, or the middle data point. The last one is the mode. The mode represents what data value occurred the most, so which one repeated the most. So this is just kind of a brief overview of some things we're going to be talking about moving forward.